Okay, for the rule of 72 is the number of years that it takes to double your money. So you could do 72 divided by an annual compound interest rate. And it's not exact, but it'll kind of give you an estimate. So have $1,000, how long to double the money if earned 10%. So you take the 72 divided by 10 and it gives you 7.2. And so it's telling you it takes about 7.2 years to double your money at that interest rate. And you can check it. So you can do the future value factor, 10% in 7.2 years. Okay. And if you look that up on the table, or you could do 1.1. So you can always do 1 point, whatever interest it is, and raise it to the number of years. That will give you 1.986. Okay. So, if you would get $1,986 in 7.2 years, which is almost double. So it's not exact. It's just an approximate amount of time it would take to double your money. All right. Present value is the value today of an amount to be received in the future. Okay. It is the amount that would have to be invested today at this rate for this amount of time to get me to some future amount. So the present value of $1,210 to be received in 2 years at a 10% return. So how much do I have to invest today to get it to grow to that? So what you do is you do 1 divided by 1.1 to the second. Okay. Or you can go to the present value, look up the present value factor. So if you went to Appendix C and looked up 2 years and 2 years and 10%, you will get that 0.826. So I always like to use the table. If you multiply 1,210 times 0.826, it will tell you you need $1,000 now to invest at 10% for 2 years. Okay. And then if an annuity would work the same way, but you would have a different table that you would have to use. All right. Inflation is the most prominent source of investment risk. So if inflation is 4% per year and your investment return is 3% per year, at the end of the year, you will be able to purchase less than you could have purchased at the beginning of the year. Okay. Nominal rate of return is not adjusted for inflation, and then real rate of return is adjusted for inflation. So nominal is not, remember, no, not adjusted. The real rate of return is adjusted for inflation. So the real rate of return may be approximated by subtracting the inflation rate from the nominal rate. So if the nominal rate is 4% and inflation is 3%, well, the real rate of return is going to be 1%. As Yogi Bear said, a nickel ain't worth a dime anymore. That's kind of how inflation works. It's not worth as much. Okay, and this is the Fisher equation. The approximation does not consider compounding of interest. Okay, and here it is. If the nominal rate is 8% and the inflation rate is 3%, the real rate would be 1 plus 0.08 divided by 1 plus 0.03 minus 1. So if you plug those in, it would be 4.85% would be your rate. Okay, that would be your real rate. So you're just plugging in 8% here and 3% here, but changing it to a decimal, so 0.08 and 0.03. And that is the end. Let me know if you have any questions about this chapter.